This is Mr. Precella, and today we're working with the present value of ordinary annuity formula. I've already stated the formula and discussed what each variable stands for. Capital P is present value, R is the periodic payment, I is the interest rate per period, N is the total number of payments. And I thought we'd do some homework problems. Number 1 says, let's see, find the present value of an ordinary annuity. So it can't be much doubt as to which formula you're supposed to be using. It tells you present value of an ordinary annuity, which has payments of $1,700 per year. So R, the periodic payment, is $1,700 for 10 years at 6% compounded annually. I is the interest rate per period. Well, 6% compounded annually, well, there's one annual period per year. So compounded annually, 6% compounded annually would mean I is just 0.06. If it had said semi-annually, then 0.06 over 2. So 3% then. And N is the total number of periods. Well, how many annual periods are there in 10 years? Well, there's one annual period per year times 10 years. So altogether, there are 10 annual periods per year. Now, I'm going to just plug into this formula. P equals 1,700 times 1 minus 1 plus I. I'm just going to go ahead and add 1 plus 0.06, that's 1.06, to the negative N, that would be to the negative 10 power, all over I, 0.06. That's a negative 10 there, negative N, negative 10. I know it's sort of hard to see. The way I will calculate this is doing the bracket number first. When I punch in that bracket number, let me clear all of that. When I punch in that bracket number, what I generally do is hit, let me see, I'll do the top and then hit enter. Let's see, is this hard to see? 1 minus let me see, so much glare, 1.06 raised to the negative 10, hit, hit enter, and then divided by 0.06. So there's my bracket number, times 1,700. So our present value of this ordinary annuity is $12,512, and rounding to the nearest cent, 15 cents. $12,512.15. Okay. Now let's see. Let's do another one. Problem 2. Oh, there goes the light switch cutting off. There's a crazy motion sensor in this room, and if we don't move around a lot, it's going to cut off. So there's nothing wrong with your computer, whatever you're watching this on. Problem 2 says find the payment made by the ordinary annuity. So here's our present value of an ordinary annuity. We want to find R. Find the payment made by the ordinary annuity with the given present value. So the key words, present value, ordinary annuity. So we use that same formula, which I have written right here, but it might be hard to see it because it's so small. So it's R times 1 minus 1 plus I to the negative n all over I. Okay? So find the payment. So the R is what we're trying to find. So let me just identify our unknowns. Our unknown, R question mark. With the given present value. So here's the present value. 84,519. Monthly payments for 19 years. Interest rate is 5.4% compounded monthly. To get that, I'm going to find, let's see, N. Monthly payments for 19 years. Well, how many payments altogether? 12 times 19. Let me see. 12 times 19 is 228. And I is the interest rate per period. Well, if it's 5.4% compounded monthly, I is 0.054 over, how many months are there in a year? Well, 12. So 0.054 divided by 12 is can you see that? 0.0045. I just punched that into my calculator. So now plug it into the formula. 84,519. I'm putting this in place of P. R is what we don't know. 1 minus, now 1 plus I, move over. 1 plus I, I'm just going to go ahead and do that calculation in my head. 1 plus 0.0 whatever is 1.0045 to the negative n all over I. So I'm going to calculate the bracket number, and then what am I going to do? Multiply or divide to solve for R? Divide. Did y'all hear that? So let's plug in and find the bracket number. Okay. My calculator. Oh wait, clear. One. Oh, it's hard to see, isn't it? Minus 1.0045 raised to the negative 228 power. Hit enter. And then divided by 0.0045, enter. So there's the bracket number. Ooh, can y'all see that? 142.3858.271. Now don't round until we're completely finished. So you're going to go 84,519 divided by second A&S equals, let me run. 593.59. Okay, so if you want to have 84,519, oh wait, no, excuse me. So if you were buying a house costing this much with these terms, then the payment would be 593 point. Does it ask to put it in dollars and cents? Yes, 59. 593.59 would be the monthly payment. If you had an annuity that was going to be paying you money every month for 19 years at this interest rate, this is how much you would get. It's also the same as calculating the house payment if you were buying an $84,519 house payment. But we'll get to calculating mortgage payments in a moment. I'm getting ahead of myself. Number 3, find the lump sum deposited today that would yield the same amount as payments of $15,000 at the end of each year for 19 years at an interest rate of 7% compounded annually. This is number 3, and I'm going to draw a little timeline. Find the lump sum deposited today. So are we looking for a future value or a present value? A present value. That would yield the same as payments of $15,000. Is this an annuity? If it's talking about payments, then yes, it certainly is. Payments at the end of each year for 19 years at an interest rate of 7% compounded annually. This is another one of the present value of an ordinary annuity formulas. How did I know that? Well, it says find the lump sum deposited today. We're not trying to figure out how much will be in the account after 19 years. We want to know what amount deposited today will yield the same as payments of $15,000. Well, which variable is payments? Well, R. Okay. R is $15,000. At the end of the year for 19 years, at an interest rate of 7% annually, I'm using, maybe that orange is hard to read. Oh, well, maybe it isn't. 7% annual, that would be 0.07 over 1, so I is just 0.07. I is the interest rate per period. Here's a little interest rate per period. It's lowercase I. Lowercase n is total number of periods. Well, if we have 19 years and it's all annual, then n is just 19. So here's one where you just plug in. You're given R, I, and n. Just plug in to find P. So 15,000 times 1 minus 1 plus I would just be 1.07 to the negative n all over I. So I'm going to find the bracket number and then do what? Multiply or divide? Multiply. Okay? So multiply. Let me clear all of that. Let's see. 1 minus, that's sort of hard. 1 minus 1.07 raised to the negative 19 power, then hit enter, divided by you'll see that? I went divided by, so it says answer divided by 0.07. And then now multiply by 15,000. So $155,033, and what is that, 93 cents? So here's the lump sum that you could deposit today that would yield the same amount as making yearly payments of $15,000 for 19 years. This amount will grow to the same amount as making yearly payments of $15,000 at the end of the year for 19 years. So there's your choice. Either make deposit $15,000 into the account every year for 19 years, or just put $155,033.93 in it right now, and it'll grow to the same amount. Now, number 4 says find the payment necessary to amortize a 4% loan of $1,900 compounded quarterly with 12 quarterly payments. By amortize, you mean pay off a loan with a series of equal periodic payments. Amortize means pay off loan with a series of equal periodic payments, like a car payment or a house payment. Okay. So on this one, number 4, find the payment necessary to amortize a 4% loan of $1,900 compounded quarterly with 12 quarterly payments. So we have 12 quarterly payments, so that's the number of payments. That's N. Okay? So on number 4, I'll write it right here. N is 12. A loan of $1,900. Well, if you have a loan of $1,900 that you're paying off, is that $1,900 a future value or a present value? Well, that's the present value. $1,900 is the amount that you owe today. If you're going to pay it off in 12 payments, 12 quarterly payments, then at the end of the 12 quarterly payments, how much should you owe in the loan? Well, if you're going to pay it off, you should owe 0. Okay? The significant thing is the $1,900 is a present value. Is this an annuity? Are we paying it off? Are there going to be a series of payments? Well, yes. This is another present value of an ordinary annuity. It's going to be important that you be able to tell these things apart. Why am I choosing present value rather than future value? The $1,900 is not a future value. It's the amount of the loan today. So we have N equals 12. We need to calculate I. I is 4%. The interest rate is 4% compounded quarterly. So how many quarters are there in a year? 4. So 4% compounded quarterly is like 1% each quarter. This problem is going to be like number 2, which we did earlier, where you're trying to calculate the payment. Okay? We're finding the payment. So plugging in 1,900 for P. R is our unknown. 1 minus 1 plus I. I is 0.01 to the negative N all over I. Okay. So I'm going to punch in the bracket number. Oh, let me clear all of that. So we have 1 minus 1.01 raised. There goes those lights. When that happens, wave your arms around, do something. Raised to the negative 12 power. And I'll hit enter. And now I'll say divided by 0.01. So that bracket number is 11.255, blah, blah, blah. Well, to get R by itself, we would have to divide by that number. So I'm going to go 1,900 divided by second A&S, pulls up all of that. Enter. So the payment is $168.81. So maybe some young guy's gone and bought a $1,900 stereo in his car. And he's going to pay it off over 12 quarters, which would be what, 3 years? How much does he have to pay every quarter? Well, $168.81. Okay. Any questions there? Now, number 5. Oh, I think it's very much the same type of problem. Let me see. Is number 5 just like number 4? Maybe I won't have to do it this one. Oh, wow. Yes, you do the same thing. N is 18. I, it's 4% compounded quarterly. Oh, wow. This one's so similar. I is still 0.01. And P, the present value, is 1,400. So just to move things faster, I'll just say to do number 5, you do it just like number 4. Now number 6. Here's a really good one. Number 6. Find the monthly house payment. Find the monthly house payment necessary to amortize a 6.0% loan of $241,500 over 25 years. So they're going to pay off this house over 25 years by making monthly payments. If we think in terms of a timeline, sometimes students say, well, how do I know which formula to use? You first ask yourself, is this an annuity? Is it a series of equal periodic payments? Well, yes, monthly house payment. Then it asks, then you ask yourself, okay, this dollar amount, the $241,500, that's the loan value. Is that the value of the loan today? Is that how much you owe today or after the 25 years? Well, that's the amount you owe today. It's $241,500. That's a P, a present value, and it is an annuity, so this is present value of an ordinary annuity, that same formula we've been using. Now, at the end of the 25 years, you hope that the amount that you owe on the house is 0. Okay? So let's see. P is 241,500. I, let's calculate I. I is the interest rate per period. The interest rate is 6%, so 0.06. And now this is assumed to be monthly. The interest rate and the payments always correspond. So if this is a monthly house payment, how many months are there in a year? 12. So 0.06 over 12. Punching that into your calculator, is that a 0.005? Now, N is the total number of periods. Well, how many monthly house payments are they going to be making over the 25 years? 12 times 25. Let's see, is that 300? So this is another one like where you're calculating the payments, like 4 and 5. So we're going to plug in these numbers. Let's see, what are we going to get? 241,500 equals R times 1 minus 1 plus I. I'll just do that in my head. 1.005 to the negative n all over I. So I'm going to punch in all of this and then divide. So let's see. Okay. 1 minus 1.005 raised to the, what is that, negative 300? Then hit enter. 0.7768 divided by 0.005. What are we getting? A 155. Ooh, let me see. Right? 0.206. And now I divide. 241,500 divided by second A&S. Okay, so the payment $1,555, and rounding to the nearest cent, is that going to be $99? Now this is what's referred to as just the PIP. It's a principal and interest payment. It isn't covering insurance or taxes. This is just the amount that covers the loan, not insurance and taxes. Okay? You may be paying insurance and taxes into escrow. Okay? So this is the payment that will cover just those first few, just the interest and principal. It doesn't cover taxes and so forth. So that's how you calculate any of the monthly house payment problems. Okay? There's going to be, I think I have several of these. Y'all caught up with me? Are there any questions? I'm sort of going through this quickly, aren't I? Let's see, that was problem 6. Oh, let's see. What about number 7? I think number 7 is the exact same type of problem. Let's see. Find the monthly house payment. Okay? So I is the interest rate is 7.2%, and it's monthly, so 0.072 over 12. That's 0.006. Let me slow down a moment. Okay, it's the same type of problem, except the house is $135,500. So that's P. The interest rate is 7.2% compounded monthly. So there's 12 months in a year. And this is another 25-year loan. Usually you see 15 or 30-year, but I guess there's no reason why you can't have a 25-year loan. So 300 periods altogether. Using that same formula, present value of an ordinary annuity. I'm going to plug in here 135,500 equals R. So it's 1 minus 1 plus I is 1.006 to the negative N all over I. Here. Now let's see. Touching it. 1 minus 1.006 raised to the negative 300 divided by 0.006, and then divide. 135,500 divided by second A&S equals $975.04. Ooh, can y'all see that? $975.04 is the house payment there. Again, not including interest and taxes that you might have to be paying also. Oh, wow. Only one more to go. So, number 8. A new employee, did someone's phone go off? A new employee charged $5,460 on a credit card to relocate for his new job. After noticing that the interest rate for his balance was 15% compounded monthly, he stopped charging on the account. Wow, that is a pretty high interest rate. He wishes to pay off the balance in 3 years using automatic payments sent at the end of each month. What monthly payment must he make to pay off the account at the end of 3 years? Well, this is a periodic compound amount formula, and how do we know that? Well, the present value, it's not a periodic, it's a present value of an ordinary annuity formula. Sorry about that. How do we know that? Well, is it an annuity? Is there going to be a series of equal payments? Well, yes. Okay? This $5,460, is that a present value or is that a future value? Well, it's a present value. He's going to pay off that credit card. In the future, at the end of the 3 years, he wants that balance on the credit card to be $0. The $5,460 is how much he owes right now. So that's a present value. 15% compounded monthly. So, let's see. So, we have the present value of an ordinary annuity. So let's see, what are we given? Well, we're trying to find R. Okay? What monthly payment? P is $54.60. I, pardon me, 15% compounded monthly. That's 0.15 over 12. Let's see, what does that reduce to? 0.0125? Oh, pardon me. N is the total number of payments. If he's making monthly payments for 3 years, what two numbers do I multiply? Well, 12 times 3. So altogether, he's making 36 monthly payments. So plugging in, 5460 equals, R is our unknown, 1 minus 1 plus I is 1.0125 to the negative N all over I. Let me see. I'll clear this. So I have 1 minus 1.0125 raised to the negative 36. Then I'll hit enter. Okay, so we have that. Can you all see that? And now divide by 0.0125, 28.87, and so forth. Now divide 5,460 divided by second A and S. So $189 and is that 27 cents? So how much should his monthly payments be to pay this off? $189 And on B, it says how much total interest will he have paid? Well, the total interest, let's think about how much he paid altogether. If he's paying this much for 3 years monthly, then to calculate the total amount he paid, you take the monthly payment, multiply by 36. That's going to get you the total amount he paid, but we then need to subtract the $54.60. That'll tell us how much interest he's paid. 189. Oops, clear. 189.27 times 36. So altogether, he's paying $6,813.72. But let's subtract the $54.60, and that's going to get the amount of interest. So the amount of interest that he's paying is $1,300. Ooh, too dark there, isn't it? $53.72. 1353.72. So now 9 and 10 I've already done in other videos, but you know what? Let's go back. I like what we just did there, calculating the total amount of interest. What if we had done that on this problem right here, number 7? We calculated the monthly house payment. So this person's going to be paying $975.04 a month for 25 years. So I'm through with those problems. I'm just curious, what's the amount of interest this person is going to pay? If you want to calculate that amount of interest, if you went 975, let's see, 975.04 times 300, this person's paying $292,512 for that $135,500 house. Okay? Now let's subtract that $135,500. Do you see what I'm doing? Any questions? I've gone back to number 7 where we calculated a house payment. And now we're calculating, well, how much interest is this person paying? Over the life of the loan, this person is paying $157,012 in interest. Right, in interest on the $135,500 loan. They're buying a house that costs $135,500. They pay $157,012 in interest, along with the $135,500. So altogether, that house is costing them $292,512. That's a very interesting thing to do there. Okay? Calculate the amount of interest. It's too bad the problems didn't ask us, like on number 6 when we calculated the house payment. We calculated a payment of, what was it? $1555.99. That was the answer on number 6. Yeah. So how much interest did they pay over the life of the loan? Over the life of that loan. But we're out of time now. So thanks for listening, watching, and again, the last 2 problems, 9 and 10, I have separate videos of those. Okay? So have a good day, and thanks for watching. The next assignment, all of this stuff is put together, and you have to figure out, is it a future value, formula or present value of an annuity formula and so forth. So thank you. Bye-bye.